A single drop of water falls in slow motion, glistening in the light. But if we could zoom inside, we'd uncover something astonishing. A whole world packed with life forms that look more alien than anything in science fiction. What seems empty to the naked eye is actually a bustling ecosystem, with predators, prey, and survivors all fighting for existence inside that tiny droplet. The microscope revolution. For most of human history, a drop of water looked perfectly ordinary, clear, pure, and lifeless. People had no idea that hidden inside was an entire universe of activity too small for the eye to see. That mystery began to unravel in the 17th century, when Dutch tradesman Antony van Leeuwenhoek perfected simple microscopes that could magnify far beyond anything of his time. Curious and meticulous, he peered into a droplet of pond water and discovered what he called animalcules. Tiny creatures swimming, twisting, and feeding in ways no one had ever imagined. The microscope changed everything. Suddenly, what seemed invisible was revealed as a teeming jungle of life. Scientists realized that water wasn't empty, but crowded with countless organisms, from simple bacteria to complex microscopic animals. This discovery opened the door to microbiology. What van Leeuwenhoek found was just the beginning. Every improvement in microscopy since then has shown us even more detail and complexity inside a single drop. And today, with modern lenses and electron microscopes, we can see this hidden world in breathtaking clarity. Segment 2. Bacteria. The invisible majority. Inside a single drop of water, bacteria are by far the most abundant residents. Billions of cells can be packed into this tiny space, forming a community so dense it would rival any bustling city. These microscopic organisms are the recyclers and engineers of the droplet, breaking down organic matter and releasing nutrients that other life depends on. Some bacteria capture energy from sunlight, others feed on waste, and a few are capable of producing toxins that can harm larger creatures. But whether helpful or harmful, their presence is essential. Without bacteria, the balance of life inside the droplet would collapse. They form the very foundation of the microscopic food web, providing a constant food supply for the predators that roam above them. In a way, bacteria are both the builders and the base layer of this tiny universe, unseen yet absolutely critical to its survival. Protozoa, the predators of the drop. Protozoa, such as paramecia and amoebas, turn the droplet into a battlefield. Unlike bacteria, these are single-celled organisms with more complex structures, giving them surprising mobility and versatility. Paramecia swim with hair-like cilia, gliding swiftly through the water. Amoebas extend flexible arms called pseudopodia, engulfing prey in slow but relentless fashion. Other protozoa whip tails, or flagella, to dart after their targets. Their diet is simple but vital. They consume bacteria and smaller microbes, keeping populations under control. Yet despite their role as predators, protozoa are also prey themselves, falling victim to larger microscopic animals. This constant push and pull creates a delicate balance, where survival depends on speed, strategy, and adaptability. Within the space of a single drop, protozoa embody the drama of predator versus prey. Rotifers and tardigrades, the tiny animals. Zooming in further, we find creatures that almost seem too advanced to live in such a small world. Rotifers are tiny multicellular animals equipped with rings of cilia around their mouths that spin like wheels, drawing food into their bodies. Despite their size, they have stomachs, muscles, and nervous systems, functioning like miniature versions of larger animals. Alongside them lurk tardigrades, the legendary water bears. These stubby, eight-legged survivors are famous for their resilience. A tardigrade can endure freezing cold, boiling heat, crushing pressure, or even the vacuum of space by curling into a dormant state. Finding them in a droplet reminds us that complexity and survival go hand in hand, no matter the scale. Together, rotifers and tardigrades prove that even within a speck of water, life can take remarkable advanced forms. Creatures that not only survive, but thrive in one of the smallest universes imaginable: algae and microscopic plants. No ecosystem can survive without a source of energy, and inside the droplet, that role belongs to microscopic plants. Green algae, diatoms, and cyanobacteria capture sunlight through photosynthesis, producing food and releasing oxygen. They are the primary producers, fueling the rest of the food chain. Diatoms, with their intricate glass-like shells, turn the droplet into a gallery of delicate patterns, while green algae create bursts of color invisible to the naked eye. Cyanobacteria, some of the oldest organisms on Earth, remind us that photosynthesis began with microbes like these billions of years ago. Inside a single droplet, they continue the same ancient work, turning light into life. Without algae and microscopic plants, this hidden world would collapse into darkness, proving that even the tiniest ecosystems depend on sunlight to thrive. Why it matters for us. At first glance, the life hidden in a droplet may seem far removed from our daily concerns. But studying these tiny organisms reveals powerful insights into life itself. Microbes in water help scientists trace the earliest steps of evolution, showing how simple cells gave rise to complex ecosystems. They also provide clues about how life might exist on other worlds, where entire alien biospheres could thrive unseen. For humans, these microscopic communities matter in practical ways too. Many of the microbes in water are essential for producing oxygen, recycling nutrients, and keeping natural systems balanced. Yet others remind us of danger, as waterborne diseases like cholera or giardia come from organisms that share this same hidden world. By understanding them, we not only protect public health, but also learn how delicate our relationship with water truly is. Every sip, every raindrop, every puddle is more than just liquid. It is a universe of survival, innovation, and hidden beauty. The study of a single drop connects directly to our own existence, proving that the smallest worlds can teach us the biggest lessons about life. Inside a single drop of water lies an entire hidden universe. Microscopic hunters chase their prey, plants create energy from light, bacteria recycle the remains, and tiny animals like rotifers and tardigrades endure against the odds. In that small world, predators, prey, survivors, and builders all play their roles, proving that life flourishes even where we least expect it. The next time you watch a raindrop slide down a window or take a sip of water, remember, you're holding an ecosystem. And here's the thought that lingers. If a single drop can hold so much, imagine the mystery still hidden in entire oceans. What new worlds remain unseen, waiting to be discovered? Thank you for joining this journey into the unseen. If you enjoyed exploring the secret universe inside a droplet, don't forget to like, share, and subscribe for more hidden science stories that reveal the extraordinary and the ordinary.